So I want to end this section with kind of an interesting theorem, which again has a name, and the name is and absorption. We can actually use that as one of our explanations later. And what the theorem is that x or y, we take that and then we and y again. So x or y and y is actually the same as just y, right? That's the absorption. The and y completely absorbs that left-hand side. So let's look at the proof. We'll have x or y and y. That's the left-hand side. That's how we always start, right? And what I want is to kind of isolate the y. So let's rewrite that to x or y and y or false. Okay. Now, the strategy here is I'm going to try to use the distributive law to take that y out of there. So that's why I added y or something. So I can do this simply by or identity. Okay, so like I said, I'm going towards the distributive law. I have y on both sides, but it doesn't come in the same order, and it needs to. So let's just rearrange the order. This is y or x and y or false. And the reason I can do that is, of course, because or is commutative. And again, that's one of our axioms. And now I have and I have these y's in the front, okay? And those are applying to ors in both cases. So the distributive law will now apply. I can pull the y out in front, and what I have is y or x and false. And that's just distributive. I should call it or distributive. Okay, so y or x and false. And of course, this is simply y or false. That's because x and false is always false, and we have a rule for that, which is and null. Okay, and y or false, well, that's just the same as y. And this is or identity. Okay, so that's the proof. It's a little involved. In my experience, actually, students get pretty good at finding these, and the reason for that, I think, is that basically what we're doing is programming, isn't it? I mean, we have a set of things that we can do. Those are like your base functions, right? And then you have a goal, and to try to get that, you have to somehow get those base functions one after another in the proper order. That's pretty darn close to programming. So this is the kind of thing that I expect you to get pretty good at here in the next week or so.